Good morning. Well, we already had a great start for the day, and the weather is gorgeous. I try to tell everybody that it's just like this all 365 days, especially when we are recruiting people to Oak Ridge. Welcome. I think it's a pleasure and a privilege on behalf of Johnny Moore. Where is Johnny? Oh, there it is. On behalf of Johnny Moore, the site manager for Oak Ridge National Laboratory, DOE site manager for Oak Ridge National Laboratory, and myself, it's my pleasure to welcome you to Oak Ridge National Laboratory. Thank you. Thank you for coming to the third InnovationXLab Summit presented by the U.S. Department of Energy. The department is holding these events to showcase the assets of its national laboratories and to assist private companies, investors, universities, and other organizations in using these assets as a source of innovation. We are pleased and proud to have been selected to host a summit which is focused on advanced manufacturing. It's really an important topic. The U.S. manufacturing sector uses approximately 25% of the nation's energy, and energy obviously represents a significant cost in manufacturing. In addition, innovations in manufacturing processes and materials are vital to the efficient and competitive manufacturing of a variety of energy-related products for nuclear power plants, and all the way to wind turbine blades. For these reasons, the Department of Energy is making substantial investments aimed at accelerating innovation in manufacturing. For example, the manufacturing demonstration facility that ORNL hosts for Department of Energy, which some of you visited yesterday as part of the tours, helps industry to develop and adopt new manufacturing technologies to reduce life cycle energy, cut production costs, and create new products and high-paying jobs. I hope you had a chance to chat with some of the graduate students who are working at the MDF. They are benefiting from the department's investment in developing a workforce with the skills needed to take advantage of the new manufacturing technologies that we are developing here. So are the young entrepreneurs who are participating in the department's lab-embedded entrepreneur programs. Innovation Crossroads at Oak Ridge, Cyclotron Road at Lawrence Berkeley, and Chain Reaction at Argonne National Laboratory. Another example is DOE's program in high-performance computing for manufacturing. The HPC for Manufacturing program puts some of the world's most powerful resources for modeling and simulation and data analysis, including those here at ORNL, to work on the challenges of cutting production costs and reducing time to market. Other scientific user facilities at the DOE National Laboratories are also available for addressing problems in manufacturing. For example, we've used our spallation neutron source to investigate the performance of a new aluminum alloy in a gasoline-powered engine while the engine was actually running. The alloy was developed through the Critical Materials Institute, which is sponsored by DOE's Office of Energy Efficiency and Renewable Energy. The developers also used the molecular foundry at Lawrence Berkeley National Laboratory and the advanced photon source at Argonne National Laboratory. Their alloy has been licensed by EC Industries, which was part of the development team. The exhibits on display today and tomorrow will provide you with the opportunity to explore similar stories of how the national labs bring their resources to bear on industry needs. I want to give you a quick preview of 3 of these exhibits to whet your appetite. The Secretary earlier in the day talked a little bit about transformational challenge reactor or 3D printing reactor. Because of our history at ORNL, we have unparalleled assets in nuclear science and engineering. We also have remarkable capabilities in materials, manufacturing, instrumentation controls, and computing and artificial intelligence. Through our Transformational Challenge Reactor program, we are applying these resources and those of our industry partners to 3D print a small reactor, a microreactor. We expect this program to develop and deliver advances with the potential to transform the nuclear power industry. We hope that what we are printing is our 14th reactor this laboratory has built in its history. Another exciting display is by a small company, HTS International. They supply specialty products to injection molding and die casting industries. In many ways, what we are trying to capitalize on 3D printing the reactor is what HTS is trying to capitalize in their molding, dies for injection molding and die casting industry. By wrapping around the cooling channels around the die cavity, they are able to extract heat much more efficiently. So imagine a small company, right? Their goal is simply to have a minimum of 10% impact on this, injection molding die casting industry. Now let me tell you what that means. It's a $300 billion global business. A 10% improvement in cycle time is a minimum of $30 billion savings. And they are actually moving their headquarters and manufacturing facility right next to MDF in Hardin Valley. And so that's really another exciting story that you will get to see. And I hope you will get a chance to meet with them. And likewise, Gate Precast. ORNL partnered with Gate Precast, which manufactures precast concrete systems, to develop and 3D print a set of molds that were used to precast concrete parts for the facade of the 42-story Domino Sugar building in New York City. You will see one of those a piece of that facade out in the courtyard. The molds were made of carbon fiber reinforced ABS and reinforced with chopped carbon fibers. Each 3D printed mold could cast at least 200 concrete parts, which was key to meeting the project schedule. All of the exhibits showcase innovative applications of materials, technology, and expertise available from DOE facilities. So please explore these exhibits and talk to the exhibitors. They've taken the time and effort to be here to engage with you. It's a great opportunity. And please use the networking and breaks to engage with your fellow participants. We look forward to the new partnerships and innovations that will emerge from both the scheduled and unscheduled discussions, conversations, and interactions. Staff from DOE's Office of Technology Transitions and many ORNL employees have invested an extraordinary amount of effort in preparing for the summit. I thank them, and I'm confident that their efforts will result in a successful event. But if there is anything at all that we can do to assist you, please let us know. We have a full agenda, and I know we're a few minutes late already. So I'll just take this opportunity to say how much we appreciate the presence of the Secretary of Energy, the Honorable Rick Perry. This is his third visit to Oak Ridge National Laboratory. He was always a welcome guest. Secretary Perry just announced a contract with Cray and AMD to build a Frontier supercomputer at Oak Ridge. Frontier is anticipated to debut in 2021 as the world's most powerful computer with a performance of greater than 1.5 exaflops. We expect Frontier to change the world in a host of areas, including many that you will be discussing at this event. And I expect that Secretary Perry will have more to say about this in his keynote speech. Now, some of you may already know him, but I want to take particular pride in introducing the Chief Commercialization Officer, Connor Prochaska. Connor, thank you for being here with us this morning, and I will turn the program over to Connor.
Thank you, Thomas, and I'd be remiss if I didn't start by thanking you and the amazing Oak Ridge team for all the work that they've done. It's really been a pleasure working with Oak Ridge and the Office of Technology Transitions, all the hard work that went into this. Thank you very much. Thank you, Undersecretary DeBar, for the vision for the XLab series. Thank you, Undersecretary Menzies, for your continued support. Thank you, everyone, for being here today. I'll keep it quick. I've got a talk tomorrow. I just get a privilege here, and it's pretty exciting. What is the Chief Commercialization Officer? That's a new role the Secretary created in November. As the Chief Commercialization Officer and the Director of the Office of Technology Transitions, my responsibility and my charge is to be the front door of the Department of Energy. When you if you've ever seen, raise a hand if you've seen the Forrestal building, our headquarters building in D.C. It's not the prettiest building in D.C. And if you look at it, you literally can't find the front door to the building. So we hope to be your front door. We're doing that through smart policies that'll help you work together with the Department of Energy. We're doing that with access through things such as our labpartnering.org service, which we've got the booths out front, and I encourage everyone to go check out the booths that are out there representing all of our labs and facilities. And then finally, it's doing things like XLab and promoting the amazing work that the Department of Energy does and the complex does it. Why do we do all this? We do this because we want to maximize the impact of the U.S. taxpayers' research and development dollar and change the world. Leading the charge of making the biggest impact is someone who has continued to make an impact throughout his career, starting as an Air Force veteran, a rancher, the longest-serving governor of the state of Texas, and now is the 14th Secretary of Energy. Ladies and gentlemen, please welcome Secretary Rick Perry.
Yes, sir. Life is good. Life is good.
Good to see you, man. Thank you for being here.
Thank you.
Is this it? All right. I'm sorry. I was standing out there in the bright sunlight, and you all are just now coming into focus. Anyway, so how are you? My nuclear man. It's good to do. And Susie, my nuclear woman. We have. I'm telling you, I'm the most blessed guy in the world to get to work with the people I do. I know y'all have heard that before, but I can't say it enough. And Connor, thank you for you and your team. Our new Chief Commercialization Officer, and which is again a lot of what we do at DOE is messaging. A lot of what I do at DOE is messaging. A lot of really smart, capable people actually get more concrete results than we do with our messaging, but it's important to do that too. And so, Connor, thank you for what you do. You and the OTT team have done a great job of putting these XLabs together across the country. And Thomas, I don't know there you are. Thank you, brother, again for what you and Oak Ridge do, and for hosting us here again, and making us feel at home. And this is this whole advanced manufacturing concept that's going on is just, it's really exciting. It's just there's so much runway in front of us, as I like to refer to it, and the supercomputing, the nuclear science, all of it coming together in a way that we're able to show the world the great potential that's here. And Paul DeBar, Undersecretary for Science, Mark Menzies, both of you in your roles, I want to say thanks to. They're critical members of our leadership team over at the headquarters. I feel very confident as I travel around. I spend a lot of time in Europe and the Middle East, and I think next week we're going to be down in Colombia with again with our very dynamic story, and I feel very confident being able to leave the agency in amazingly good hands as I travel and do that. So to both of you, thank you for what you do, and thanks for being here today. It's good to get you out of Washington from time to time and show you off a little bit. So Mark and I just got back from Brussels together, and so Congressman Fleischman's not here, is he? I think he's coming. But anyway, you all have two just amazing people who represent this lab and this area. Obviously, your Senator Lamar and I are particularly close. He is an incredibly gifted, talented guy. And not unlike me, he can't keep a job. Been the governor, been the
I think, Secretary of Education. He was the president of the University of Tennessee. Now you're a United States Senator. We jokingly make fun of each other that we can't stay settled in one place, but he is a truly, if there is a stronger advocate for Oak Ridge, I don't know who it is. He and Chuck Fleshman do fabulous work for this laboratory and for this region. So anyway, when you see them, just tell them thanks. I mean, it's not easy work what they do. So I talked about this really fascinating time that we're in. I refer to it as the new American energy era. I think back of historically when I got out of college at the beloved Texas A&M and went into the Air Force. We were just going into the era of oil embargo, 1973, 74 time period. You know, there's a few of you that are old enough in this audience to remember that, and this harrowing time as we saw what was going on in the world, and the United States being basically held hostage by a lack of energy resources. And then I fast forward about 30 years, and I go into the mid 2000s, and the peak oil speech that was given that the world was out of energy, and even if they found new sources of energy, they were going to be extremely expensive to produce and develop. And innovation makes fools of conventional wisdom on a regular basis, and nobody does innovation better than our national labs. You all are on the cutting edge of innovations that we'll look back on. Some proclaimed expert in a particular field will say something here in 2019 that is completely and totally wrong. It'll be because of the brilliance and the innovation and the great potential that occurred at a national lab in conjunction with a private sector partner. So anyway, this manufacturing renaissance is a great example of it. And Ed, what you and your folks are doing on the nuclear side, and what your partners over here with 3D printing and the advanced manufacturing on the cores of these reactors, particularly those micro reactors that I stood out there in front of earlier today. I mean, it's just I'm really eager about what the future is going to hold, and I think it's not. I know that's why the administration is so committed to revitalizing American manufacturing, because of when you couple that with what's going on at our national labs, John. I mean, you guys over at your place. I mean, it's a great example of on the nuclear side of things, and the manufacturing drives up more than half of our exports, 11% of our GDP, employs nearly 13 million U.S. workers. It's an average salary is well above that of what the average worker would make in this country. President Trump said that our policies have launched this unprecedented economic boom, created some 5.3 million jobs, about 500,000 new manufacturing jobs. So, and we're just at the start. And speaking of being just at the start, at the tip of the iceberg, we were in Brussels, and Fatih Birol is the He's the head of the International Energy Agency. And Fatih was talking about that we have just seen the tip of the iceberg in the Permian Basin. The Permian Basin is now the third largest oil field in the world. Saudi Arabia being number one, Russia being number two, and the Permian Basin being number three. I mean, this is fascinating. And just seeing the tip of that iceberg, this is almost incomprehensible to get your hands around, your head around, because 13 years ago, 15 years ago, they were telling us we'd found it all. And again, I go back to that it's that great American spirit and intellect and ingenuity of our innovation that I never let the conventional wisdom weigh me down too much from the standpoint of, woe is us, it's the end of the world, and there, you plug whatever issue that the wise ones say today is, here's the end of the world, whatever it is, and I will say, well, you let a national lab work on it for a while, brother. We'll see about that. And it obviously requires commitment. It obviously requires prioritization. And Mark, that's one of the things that we announced more than $79 million in funding for bioenergy research and development, awards that support our goal of providing consumers and businesses with a range of energy options that are affordable, reliable, that are secure. We're also working with the National Association of Manufacturers on the Sustainability in Manufacturing Partnership to find innovative ways to increase environmental stewardship and energy efficiency. Key element of that is a partnership with EERE and what they're doing in that shop. Better Plants program, improve our energy productivity. Nearly 30 companies have joined the program since President Trump took office. Programs like this one improve our manufacturing competitiveness, saving companies obviously millions of dollars. And they boost the wages, expand operations, they grow the economy. It's what we're seeing across our country at present. Today I'm very proud to announce $89 million for advanced manufacturing technologies. This includes the development of cutting-edge manufacturing processes to increase battery manufacturing for vehicles and stationary applications. This past March, DOE committed to establish a cybersecurity institute for energy efficient manufacturing. This will be the 6th manufacturing institute developed by DOE. Other areas of our efforts include advanced composite materials, additive manufacturing. This one will be focused on several key areas, including understanding the evolving cybersecurity threats that we have, and developing new cybersecurity technologies and sharing information and expertise with the broader community of U.S. manufacturers. We're also striving to leverage our great strengths in supercomputing. Obviously, I stood right here on this stage 10 months ago, thereabouts, and announced Summit. 5 out of the 10 fastest supercomputers in the world reside in the United States. They all reside in national labs. We're going to take on this manufacturing challenge with the assistance of those. And by the way, Thomas, your remarks this morning were really important. And I hope that the consuming public out there that have access to what you said, where you talked about, these machines are important, and our partners, Cray and AMD, and what they're doing is really important, building these computers. But it's the men and women That's frankly what nobody else has. I mean, that's the magic elixir, if you will, to this concoction. But having this talent, this commitment, this passion, this energy, where you add to those machines, and then we see that's the leverage in our supercomputing world. So one focus of our efforts is the High Performance Computing for Energy Innovation program. That's a consortium of 9 labs led by Lawrence Livermore, and they partner with the private sector, again, to leverage our world-class computing resources. As part of that effort, we recently announced $1.2 million under that program for 4 new projects to support American steel and aluminum manufacturers, or aluminium if you're from England. It took me for like weeks to figure out what they were talking about. I thought maybe they found a new element or something. Kidding. Just kidding. You know that. Having a little fun with our UK friends. You're going to hear more about the essential and challenging work that we're doing in this area at a couple of panels later this morning. So stay tuned. I'm especially excited about the potential of advanced manufacturing and, as I've said, our nuclear energy technology. Here at Oak Ridge, we're working on transformational challenge reactor project using 3D printing to build a complete demonstration microreactor. So that project, and I know it's going to be successful, and it's going to offer a way for our advanced power systems that are both scalable and economical. I think it's probably the key to America maintaining its position and frankly becoming the preeminent position in the nuclear power realm. I'm excited. I mean, Susie's working on a program that we refer to as making nuclear cool again, and exceptionally important, and showing young people the potential of nuclear power, and making the U.S. again the absolute undeniable leader in that. And because of these technologies that they're working on, we're going to be able to create some very complex designs that can rapidly be prototyped, tested, and obviously reduce the time and the money that and that's been the roadblock from my perspective on the nuclear energy side of things. We may even be able to use 3D printing for fuels for the fuels in these. I mean, that's the flexibility that gives us, and the safety that's going to come from that is just unreal. We're also investing in advanced manufacturing technologies for fossil fuels, and clean hydrocarbons are a vital part of what we're doing about the present and certainly about the future. A few weeks ago, April 12th, actually, we announced $100 million in investments for our Coal First initiative, which aims to develop coal plants of the future that will provide secure, stable, resilient, and reliable power with nearly zero emissions. And that's counter to what conventional wisdom tells us, Thomas. I mean, that's exactly what I talk about. Is, coal, bad, dirty, Don't ever tell a national lab they can't do something. Don't ever tell, the American ingenuity out there, sorry, you can't do it. We're gonna prove them wrong. And so part of this whole effort may well include the development of advanced processes for manufacturing and fabricating. And this is also something that you're going to hear a bit later in the morning, but I'd be remiss if I failed to mention our host here, again, Oak Ridge, for your efforts and the world-class capabilities in advanced manufacturing, 3D printing. That this is kind of ground zero for that from my perspective. I guess when I was here last year, I drove that 3D printed sports utility vehicle. You'll call it PUV. Yeah. And so later today, I get to drive the Cobra. The Cobra we had it on loan at the headquarters for a spell, and y'all wanted it back, so gonna borrow it again for just a short drive this afternoon. So anyway, I want to say, tell Brian Post and his team at the Manufactured Systems Research Group, thank you and for the work that they've done. And matter of fact, we've got 2 of these podiums that they built at the headquarters for myself, and I'm pretty sure they're going to outlast me and lots of secretaries to come. So anyway, thanks for manufacturing those podiums for us. Later today, we're going to hear from Senator Susan Collins via video, and we're going to talk about a partnership between Oak Ridge and the University of Maine that's going to support a very large-scale additive manufacturing project. It's bio-based plastics, and obviously a huge array of applications there, and highly recyclable. So carbon fiber technology, a lot of important manufactured applications there. Greg LeMond, those of you who keep up with Tour de France, and he has a project here that his company, LeMond Composites, started here at Oak Ridge to commercialize some of the work that they're doing, making those bikes even more resilient and lighter. And so, and that's my point about the private sector working with the national labs. Have been a big public-private partnership person for a long time. Go way back into my even my agriculture commissioner days, and then when I was the governor of Texas, to find the private sector to really leverage the tax dollar that gets spent in laboratories and various other places, and which kind of leads to a salient point here today. We invest more than $10 billion in our national labs every year. $10 billion. And the goal of this summit is to expand the commercial impact of those investments. We want to leverage those investments. The United States leads the world in research and innovation. And at DOE, we are committed to ensuring that our technologies are developed to serve the American people. That's you. Not only are you on the receiving end of it, you're on the developing end of it. You kind of get the double pat on the back here, if you will. And we're ready, we're eager, we're able to work with all of you, and that's something that I know all of us can do. We look to this future of advanced manufacturing, and we see some real opportunities in the artificial intelligence side of things as well. The machine learning. Summit is one of 3 exascale computers that, or I should say, Frontier, I guess, is one of the 3 exascale computers that we're going to be announcing, and you're just going to see the acceleration of innovation in manufacturing and a lot of these other applied areas as well. And to finish up here, and to getting the American people to understand, I think, the importance of what you do at your national labs, at our national labs, at the partnerships that get created where the private sector is partnering with us on all types of different ways, and for the Department of Energy to be involved in places that people go, wait a minute, that's not what, it doesn't compute initially when they think about it, but once they understand the interaction between the national labs, the supercomputing, and whatever that area may be, healthcare is one of them. What you're doing on cancer treatments that came out of these national labs, what we're doing on advanced manufacturing on the nuclear side, what we're doing at the headquarters with a partner out at the University of California, San Francisco, on brain science, traumatic brain injury, post-traumatic stress, the success that we're already seeing in those programs. And I'll give you an example as I wrap up here, promise. Dr. Jeffrey Manley, MD, PhD in brain science, UCSF, in a partnership with, is he using Argonne? I think he's using Argonne's supercomputers, but Muxnick's, which one of the labs he's using. Finding solutions on questions that we just couldn't answer before. For instance, we all pretty much know that on concussions, there's 3 levels, right, Mark? There's mild, moderate, and there's severe. No, there's not. There's 28 different definable levels of concussions. And with all of that added in the mix, Dr. Manley developed a device about the size of your iPad, 3 inches or so thick, and take a drop of your blood, Thomas, and tell in 10 minutes whether you've been concussed or not. That's where Americans go, that's what I want my tax dollars spent on, that type of research, that type of results that's making a real difference in my family's life. Whether you're a mom who's got a daughter who plays soccer who's been concussed or potentially concussed, whether your loved one's been in an automobile accident, whether you've got a soldier on the battlefield who has potentially been traumatically brain injured, whether you're the owner of an NFL football team who has been impacted by CTE. That's what DOE is all about. That's why what you do, that's why what AMD and Cray partnering with DOE is making a real difference in people's lives. Why I get up every day recognizing that I get to work with the most gifted, brilliant, substantial people that the United States has to offer to the world. And I thank you for that. Keep it up. Let's go.
On up here.
I'll put you on the right. That doesn't happen very often. Right?
No, I'm on the left here. It's kind of that's my point. Normally I'm not on the left.
Oh, okay. You can try being on the left.
I can. You know, I told somebody one day Thomas said I can try being on the left, and it reminds me. I can't remember. We were somewhere. It was in Kentucky. We were talking to a group of legislators, and they had Democrats and Republicans alike, and a young man who was representing the Democrat Party, and I told him, I said, listen, I've spent just about half of my life as a Democrat and half of my life as a Republican. So I said, there's hope for you.
It tells you're a scientist.
Yeah.
You did the experiment and decided.
Yeah.
Thank you, Mr. Secretary.
Let's stop there.
Thank you, Mr. Secretary, for your inspiring remarks. Thank you for your leadership. You and your leadership team, Undersecretary Menzies, Undersecretary DeBar, the lab and DOE has seen impressive, budget growth the last 2 years. Office of Science budget has grown by about 25% across the board, actually. And so it really is incumbent upon us to ask the question, how are we going to be accountable to the taxpayers who provide us these resources? And so you already touched on it, but I would like to ask your perspective on how DOE and its national laboratories, how do you see us, making a difference in this sort of competitive, fast-paced world?
And I did touch on it in my remarks, and we want prioritizing the budgets. I mean, for nearly 30 years of my life, I was either an agency head, the governor of a fairly big entity, and we had to prioritize. And things change. I mean, and that's one of the things that we've done, Mark, at the department, is that one of the reasons you've seen the increase in the science budget. The overall budget of DOE hadn't changed much over the course of the last 4 years, but inside of the DOE, we moved some dollars around. We've what's the proper word I want to use here? We've brought together some things inside of the agency to, from my perspective, make them more efficient and more effective. We may not have spent more money, but we've EERE is a great example of it. I think we've done some things there to some would say, oh, you're not spending enough money there, and I said, well, I think we're spending the money efficiently and effectively. We're getting results. On the science side of things, the fact is that's where the race is. I mean, that's where on the supercomputing side in particular, these aren't cheap endeavors. They're going to cost some money. And so committing the dollars and prioritizing into that area, I think, is one of the, and we're going to show good results from it. I mean, you on the nuclear energy side of things, the successes that advanced manufacturing and 3D printing is going to give to John and his company, or working with them, not give to your company, but be in a partnership with your company, is the types of things that are going on at the agency that I think the American people look at and go, keep it up. They want to see results. And, I gave you one little view into what's going on with Dr. Manley out at UCSF. And that's the type of things that the American people will look at and say, that is why I don't mind on the 15th of April sending my tax dollars to the American people, because there's places that are giving us a good return on our investment. So the continuing to have a focus on science, with that science. And look, we all understand that from time to time we go do a project and there's no there's no foreseeable, well, I'll give you a good example. The drug companies spend billions of dollars in clinical trials, and the pile that had successful drugs is probably a smaller pile than the pile over here that was not successful. Here's why we changed that scenario. Because of our supercomputing capacity and being able to do 1 billion calculations per second, we're going to go back through and run through this pile, and no telling what they're going to find out. Find that they were just a couple of trials away from having success. The tip of the iceberg that we are just seeing because of our supercomputing capabilities is stunningly exciting to me. And the progress for humanity, whether it's dealing with the environment, whether it's dealing with medicine, whether it's dealing with, you name it, quality of life issues, is enormous.
Thank you, Mr. Secretary. You touched on many of the innovations. Actually, innovations is sort of improving at the speed of information technology. Essentially, that doubling of information technology is allowing us to innovate at that rate. One of the things that is occurring, of course, is looking at the workforce, the future. In many of the areas, especially in the early days when nuclear energy originated here, DOE played an active role in workforce development because there were no departments that offered nuclear energy or nuclear engineering degrees. And so today, in AI, in computing, in additive manufacturing, there's an opportunity for DOE and its labs to innovate, but also play a role, perhaps, in workforce development.
Yeah.
Like your thoughts on...
Yeah. Getting young men and women into science and technology, engineering, math, Susie, that's kind of one of the things that you do. Making nuclear cool again. Letting these young people know that I use the example back, a zillion years ago when I was going to college, the smart kids were all headed into nuclear engineering or aeronautical engineering. In a couple of areas, they went in some other ones. Some went into veterinary medicine, like I did, until organic chemistry changed my life. But anyway, the point is, how do you lure young people back into these fields again? And we have some, X Labs is a great example of it, there are going to be some young people that see the exciting things that the private sector is doing with the national labs. There's another group that I got associated with back when I was early days in my governorship in Texas. I think it was like 2002 or 3, and we hosted a robotics competition in Houston, one of the regional. This was FIRST. FIRST, first. It's Dean Kamen's robotics competition. Now, this thing is massively big. I think 190 countries now compete with these teams. How many of you have seen been to one of the robotics? Good. This is like the Olympics. Literally, the pageantry and the competition reminds me of an Olympics for these kids. And as Dean Kamen says, it's the only sport in the world that every one of the competitors will go pro. And getting these kids and getting that, igniting that mental excitement about what they're doing, it's one of the good examples. And I'm sure, there may be DOE national labs that actually, or at least the contractors, that support some teams that go to this. And this is fascinating stuff. 60% are women, right, that are captains of these teams. So one of the ways to get women into the science and engineering fields is through programs like that. So as you're sitting around thinking about, how do we ignite that, interest in those young people's minds, come up with a program not unlike this, or, help them develop that. So, because STEM and the STEM effort is really worthwhile. We're going to need them all. I mean, if we're going to maintain and lead the world in supercomputing, AI, and all the different aspects of that, we're going to really need to be developing a skilled workforce.
Thank you, Mr. Secretary. I know you have a busy schedule, so I have a fun final question
Great.
for you, just to, so the President signed in the executive order on AI, and today you announced Frontier, which is going to be the most powerful AI system that's going to be deployed in 2021. Your thoughts, your perspective on how the intersection of AI and manufacturing and how that is going to transform the field.
And I think I dwelled upon that with my remarks pretty good. This is, again, I get tired of hearing the analogy of the tip of the iceberg, but it truly is. And the supercomputing. So in 1969, 70, when I was still going to be a veterinarian, and in my genetics classes, we had 10 punch. Is that the right? What's the cards that were all key punch? Mm-hmm. Is that the right terminology? Yeah. Key punch, and it was a UNIVAC computer. As big as that screen, swear to God. It was as big as that screen. You'd put it in down there, and then you'd go have, coffee or take a 3-day vacation and come back, and at the end of it, it finally spit it out. I mean, it's just, you've been there. Some of you guys are old enough to remember this. The brilliance of those who brought us to where we are today, to do a quintillion calculations per second. This is why I've got, it's a little scary, yes, but the potential to do good. We make decisions about good and bad every day, but the potential to do good for this world that is going to come from our computing capacity, capability. And at the end of that, or I should say at the start of that, is a DOE laboratory or multiple DOE laboratories across the complex. So anyway, it's an exciting time to be at the department. It's an exciting time to be at the computing, the AI, the machine learning that's going on. And for those of you who do that, my hat's off to you. God bless you.
Yes, thank you very much, Mr. Secretary.